All right, so this is worksheet 0B, just an introduction. All right, arithmetic sequences are one where there is a common difference, which means you are adding or subtracting something to get the next term. And someone said the good example was this one where they are adding 10 every time. So this would be called arithmetic. And the difference would be positive 10. Did anybody else find one where they were adding something? Number 3, what are they adding there? Okay, they are adding, but it is not a common difference. So this is called neither, but you are right. I asked if there was one where we're adding. To be arithmetic, it has to be the same number every time. Good job though, you picked. Anybody look and find another one where they're adding something the same? Number 7, that looks like a good one. They're just adding 10 again, right? I think I was going to talk about one of these fraction-y ones. The fraction-y ones are very difficult to tell what's going on. The best thing for fraction ones is to get a common denominator. What would 4/3 be if it had a common denominator of 6, guys? We just doubled that. We'd have 8, 6. We didn't really do anything. We just changed it so it had a common denominator. And then this one would be -5, 6. This would be doubled, would be -2, 6, +1, 6, +4, 6. Okay, if I got a common denominator, can you tell what they're doing there? Adding 3, 6, all right, or 1/2. So that one is arithmetic, and the common difference would be 1/2. It's just hard to tell unless you get a common denominator. All right, let's go back and talk about geometric quick. Anybody, sorry, here, let me explain. Geometric means there is a common ratio, it's called. It means they're multiplying or dividing by something. Multiplying by some R value. Number 1, I think, right? What are they multiplying here? Geometric, multiplying by 2. Number 4, geometric. Remember, you can take any term, divide it by the previous term, and see if they've multiplied by something. So that's geometric where R is 3, yes. One more anywhere? Which one? 9. 9 is good. What are they multiplying by there? Multiplying by -5, right? Geometric, okay. Yeah, 10, they're multiplying by 2 again. I think that's the same as one we might have seen up top, but can anybody tell what's happening down here? This was on 14 is the last one I want to talk about, and then we'll get away from this worksheet. But if you look at, when you're multiplying, remember, you can look separately at the top and the bottom. So what's the top multiplying by here? Can anybody tell? 3. And what's the bottom multiplying by? 4. So that was geometric. All right, fractions are painful. Positive and negative we get pretty good at eventually. All right, so that was just a quick introduction to what this unit is going to have. We are going to go to worksheet 1A, please. And take notes today on arithmetic sequences. Now, the notation for terms, you can use like x1. For some reason, they usually use A or U. But A1 would mean term 2, A2 means term 2, A3 means term 3, but they use subscripts. Does everybody understand what I'm saying? Those little numbers that are just down at the bottom, they don't mean anything in terms of like, you're not multiplying, it's just the term number, okay? So the definition of a sequence, a numerical sequence is a set of ordered values of a function whose domain consists of the set of all natural numbers in ascending order. The elements of a sequence are called the terms, okay? So we have terms. The nth term of a sequence is called the general term or variable of the sequence. So when we have something a sub n, if you just kept going, some term out here is a sub n. Just means like some term. If it's a 10, then it's a 10th term. What you need for your notes, it says the definition and an example of an arithmetic sequence. So I put something down here for you. It's an ordered list of numbers, meaning there's some kind of an order to it, where consecutive terms have a common difference, okay? Meaning you're adding or subtracting something over and over. And we use D to be that common difference. We use A sub 1 to mean the first term. And we use A sub n to mean kind of the formula. It's not really, it's some term, but we will write a formula to finding the term. So it says, let's put down an example. Somebody pick a number, any number. 4. And I'm going to pick something easy like 2. We're going to keep adding 2. That would be our sequence, right? 4, 6, 8, 10, 12. Okay, where the difference was 2 and the first term was 4. And then we're going to learn how to write a formula for that. But let's just keep going. Any questions so far? These are just patterns. I love sequences because it's just patterns. All right, when it is an arithmetic sequence, we start with some term, and then we add a difference, and then we add the difference again, and then we add the difference again. So we will say A sub 1 is the first term, and then we're going to keep adding the difference. But notice, to the first term, did we add the difference at all? No, then we added the difference once and got the second term. So to get the fifth term, say, how many differences would you have added? Only 4. Does that make sense? So we're going to say the number of terms minus 1 here. So this is called the explicit form. It says an explicit form is a sequence that allows you to find the term, the value of any term in the sequence. What you are putting in for n is the term number. So explicit is when it's based on the term number. And the explicit we are going to come up with for arithmetic is you take the first term and you add some difference, but you do it 1 less times than the number of terms. So you want the 7th term, you take the first term and add 6 differences. Does that make sense? It is written, okay, they put the D at the back, but does everybody understand that this is the same? Okay, so that formula is on your reference sheet, the gold reference sheet that you already have. So you don't have to memorize this, it's on there. Hopefully it makes sense, so you'll be able to use it. All right, then we're going to talk about a recursive formula for a sequence. Allows you to find the value of the nth term of a sequence if you know the previous term, n minus 1th term. So recursive formula, recursive form of a arithmetic sequence, anytime they ask for a recursive, they're asking you to base it on the previous term. Now, the notation for previous term is a sub n minus 1. So if I gave you term 12, you would do 12 minus 1, or term 11 would be the previous term. Okay? When you see a sub n minus 1 written like that, you just into your head need to say the previous term. Whatever a sub n is, it's the term that came before that. So when you write a recursive form of an arithmetic sequence, there's two things you need to state. You need to tell me what the first term is and what the pattern is based on that previous term. So what was the one we did a minute ago? 4, 6, 8. This was it, right? Okay. So you would tell me the first term was 4, and a lot of times they will state that second instead of first. It doesn't matter to me. You just have to have it. And the sequence is, and if it's this recursive, you say the previous term number, which would be a sub n minus 1. And then what did we do every time? What were we doing to the previous term here? Yep, adding 2. So I guess if you wanted to write down the generic, you would say a sub 1 is the first, whatever the first term is. And then a sub n would always equal the previous term plus the common difference. Previous term plus common difference. Now, that formula is not on your sheet because I hope it just makes sense. The previous term plus whatever the difference is, okay? I realize it's a lot of vocabulary, the difference between recursive and explicit. Just remember, explicit is the fancy one with the term number that's on your reference sheet. Recursive is the one where you have to just say, I know term 1 and I know what they're adding. We will practice. Ready? Everybody good? All right, please stay with me so we can quickly go through these. Can anybody tell what's happening here? I think it's, yeah, decreasing by 6. So it is arithmetic. And the difference is negative 6. You can always find the difference by taking any term, okay, and subtracting the previous term. I know that looks really messy. But remember ours that went 4, 6, 8, 10. If you wanted to find the difference, you could take 10 minus 8, right? So it's the term minus the previous term. What's happening here? Let's see, this would be, if we got a common denominator, multiply by 3, that would be 9/3. Is that something happening there? I think it is. Are they adding 5/3 every time? So that one is arithmetic. And if you could have checked, again, you could have done 3 minus 4/3, math, enter, enter, and it would have said 5/3. 14/3 minus plain old 3 that was there, math, enter, enter, and it would have said, yep, it's 5/3 is the difference. What about this one? I don't think they're adding common, are they? They subtracted 1, subtracted 4, or multiplied by something, or it's definitely not arithmetic. That's all we care about. All right. So this is just more of the same. Let's just do 8. I think you guys are good. Find the common difference and the next 3 terms. So let's work a little more with a fraction one. How could we make this have a denominator of 3? If I multiply by 3/3, I'd have negative 6/3. Is that the same as negative 2? Then I have negative 8/3. Then it says negative 10/3. If I multiplied this by 3/3, I would have negative 12/3, which is the same as negative 4. Is that easier now to tell what the common difference is? Anybody? Yep. Negative 2/3, and it says find the 3 terms after the last one. So negative 4 was the last one, but it's equivalent to negative 12 thirds. So what would the next term be? 14, right? Aren't we subtracting 2 thirds? So negative 14 thirds. And then 2 more thirds would be negative 16 thirds. And then 2 more thirds would be negative 18 thirds. But how would that be written? Negative 6. Okay, there's the next 3 terms. So that's an uglier one. This one was real easy. They were just adding 3. You don't have to do all of them, though. Find the common difference in the 52nd term. Okay, let's just do one of these. Anybody pick? Anybody? 9, 10? 9? What are they adding here? Negative 8. Everybody good? The difference is negative 8. And again, you could take any term. If they've already told you it's arithmetic, subtract the previous term, and it would give you the difference. Okay, now, negative 5 minus 3 is negative 8 would have been faster than doing the crazy one I picked. But, all right, we found the common difference. How do we find the 52nd term? Anybody think they have an idea? Take the first term and add the difference how many times? 51 times. Yep, this is the idea we're using. If we want the 52nd term, we're going to take the first term and add the difference 52 minus 1 times. So I'm just trying to be kind of overkill on the idea here. We could have certainly done it faster, but to get the 52nd term, we would say it's 3 plus negative 8 51 times. Then you can type it in your calculator or do mental math. I got negative 405, but I hope someone used a calculator so we know if I'm right. Okay, can you try 10 on your own? I think we should maybe do one more. What are they adding there? Adding 20? So the 52nd term that's a big number, I don't know. Did I get it right or not? Is that right? It's doing it in my head. Everybody okay with where we got all that? If you're not, please let me know, okay? Everybody knows D stands for the difference, can be positive or negative. N stands for the term number, okay? A sub n can be a formula. A sub 1 is the first term. Okay. Find the explicit formula. Okay, let's do 12 first. 12 is easier. What are they doing here? Subtracting 8. All right, so the explicit formula is the one from your notes that looks, or from your formula sheet, looks like this. We are still going to have an a sub n in it and an n when we're done. What is the first term we're going to substitute in is 30, and the difference is negative 8, and we are adding that n minus 1 times. Now, this is, in my mind, an explicit formula. I believe the answer key and delta math, I think they want you to simplify that. So can you do a little algebra quick? 30, if we distribute a negative 8 Is it 38 minus 8n? Or negative 8n plus 38? Okay. Should we try this one with fractions? Let's see, if we have 9/10. If we doubled the top and bottom here, we'd have 24/10. This one is 39/10. If we doubled the top and bottom here, we'd have 54/10. So what are they adding every time? Can anybody figure that out? Adding 15/10, which is really what? 3/2. Okay, so what would the explicit sequence, can someone tell me? Doesn't have to be simplified, just tell me what plugging the numbers into the original formula like this one would say. A sub n equals 9/10 plus the difference, right? 3/2 or 15/10. I really don't care at this point. And then n minus 1. Oh, I don't want to simplify this. 9/10 plus 3/2 n minus 3/2. Use your calculator. What's 9/10 minus... yeah, because this would be negative 15/10. Which would be negative 6/10 or negative 3/5. Ugh. We could have done that one with decimals and it would have been okay. All right, let's hope there's not that ugly. All right, a few more things here. This one is given the explicit formula. Can you figure out the common difference in the first 4 terms? Okay, given the explicit formula, it means it's based on a term number, n, which is the term number. So to find term 1, you put in a what? Put in a 1. And then you put in a 2, and then you put in a 3, and then you put in a 4. So if I put in a 1 here, I would have negative 3, I believe. Yes? If I put a 2 in, is it negative 303? Negative 203? Okay, if I put in a 3, I think it's negative 403. Is that right? So can you tell me what the next one's going to be, guys? Looking at it? Yep, they are subtracting what every time? So the difference is negative 200. You might recognize that number in the formula, okay? Anybody want to guess what the difference is going to be on this one, looking at the formula? I think 2.3. But again, because they've given us an explicit form, we can put in a 1 to get the first term. So 12.1 plus 2.3 one time would be 14.4. Did I do that right? Okay, and then to put in a 2 would be 12.1 plus 2.3 2 times, which I'm guessing is 16.7. And then we've kind of figured out we're adding 2.3, so I think that comes up to what, 19, the next one, exactly? And then another 2.3 would be, oh, this is hurting my head, 21.3, did I get it right? Okay, so the difference was 2.3. Seem okay so far? All right. Now we're going to talk about this weird form called the recursive form. The recursive form means you have to use this notation of n minus 1. And does anybody remember what a sub n minus 1 stands for? What are the words you need to say in your head when you see that? Previous term. Okay, make sure you say in your head the previous term when you see a sub n minus 1. So what's the first term? Do we know? Looking at this notation, did they tell us the first term? Negative 21. Do we know the difference? Remember, this read a sub n is the previous term, then what? Plus 2. So the difference is going to be 2. So what is the next term? Negative 19. Add 2 to that previous term. Add 2 to that previous term. Did we get enough terms for them? Said find the first 4. Okay, so can you try the next one on your own? How did I do without a calculator? Weren't we just supposed to be subtracting 1.1, right? Everybody seem okay? So the only thing tricky about that is knowing the notation a sub n minus 1 means the previous term. The other thing that's tricky is when you have to write a recursive form, it's not hard, but you have to remember that there's 2 parts to it. When they're giving you recursive formula, you need 2 parts. You need to tell me how to find it based on the previous term, and you always have to tell me where to start. So write the recursive form for this. At some point, you need to tell me the first term was what? 16. And then, and I don't care what order you tell me these things in. Hello?
I'm interruption.
Yes.
Hi. Do you have a second to check an email for me?
Just tell me, do you need a sub?
Yes, I do. 3B from Mr. Sweet.
Okay, yep.
Thank you. We'll send them after. Thanks.
Okay. A sub n is the previous term. How do we write that? A sub n minus 1. And then what are they doing here? Can you, let's see, they're subtracting 9, is that right? All right, I'm going to write this as 2 over 2, just so they have a common denominator. 3 over 2, 2 over 2, 1 over 2, 0 over 2. So what is the difference here? How much are they subtracting? Guys, what's the difference between 1/2 and 0? They subtracted 1/2, but it is negative because they're going down. Okay, so what would it look like? Yep, or you could say plus negative 1/2. Either way is fine. And then remember, there's 2 parts to it. You also have to tell me where they started. Yep. Seem okay? That's a little tricky to remember because it's not, that formula is not on your sheet. You have to remember what it means when it says recursive. All right, what does this say? Given explicit for an arithmetic sequence, find the recursive. Oh, okay. Well, could we just put a couple numbers in to come up with what the term looks like? If you put in a 1 and then a 2 and then a 3. If I put in a 1, I would get out a 4. Is that correct? Anybody checking me? Okay, and then if I put in a 2, I think I get out a 34. and then a 64. So it's, the first term is 4, and you're adding what? A sub n is the previous term plus 30. Notice the difference was here, but where did this negative 26 come from? Remember when we did this form at the beginning? 4 plus the difference n minus 1 times. Do you see where that negative 26 came from? It's after they simplified that form down. That's why it wasn't. All right, so this is what we were supposed to come up with. Can you try the next one? Put a 1 in and find the first term. Get negative 27. And then what are they adding every time? Yep, if you put a 2 in, you'd have 4, negative 25 would be term 2. So they're adding positive 2, yes? So a sub n minus 1 plus a difference of 2. Okay, and again, the book would, or the worksheet would put those in the opposite order, but it doesn't matter to me as long as you state those two parts. Okay, recursive is a little tricky, just got to remember what it means. All right, is this the last of it? Oh, one more kind, okay. Oh, these aren't too bad. It says find the explicit formula. We already did some like this on the front, kind of. What's the first term? This is a sub 1, so we have negative 33 plus some difference times n minus 1. This is the explicit formula, again, that's on your formula sheet. What are they adding every time? Positive 8, yes? It's going up by 8. So can you simplify that? I'm not good. 33 and 8. Is it 41? Negative 41? Did I do that right? Gotta get my fingers going. Never sure about 3s and 8s. Okay. What then we're supposed to find, it asked us to find the 30th term, which means if we've gotten this formula down, we just have to do what? Plug in 30. You certainly don't have to show as much work as I did, but is it 199? Yeah. Calculator would have been easier than my little pea brain. All right, try one more just because I think it's an easier one. Oh, maybe not. What's the difference this time? So 36 minus 2 times n minus 1. Everybody okay with where I got that? That's just the a sub n equals a sub 1 plus d n minus 1. That's on your reference sheet. Watch, you're distributing a negative there. So there's the explicit. And then to find term 30, negative 22? Do you need me to go back over something, Ryan?
No, I did it wrong.
Okay. I'm sure you're not the only one, so let me know if there's one I can go back over. All right. these are very tricky. But I think if you just use your head a little bit, you'll be all right. If you went from term 20 to term 36, don't do anything crazy, just in your head. How many times did you add a difference? 16. So 16 differences were added. So term 20 plus 16 differences gave us term 36. So if we put those numbers in, we should be able to solve. A sub 20 was a lovely 3819 plus 16 differences gave us 7019. Can you solve that? Is it 200 or 20? 200? Okay. So now what would the formula look like? A sub n equals, oh no, what do we not know? The first term. Okay, we're gonna have to use a little more mental math or a little logic here. So the 20th term was the first term plus how many differences? Not 20 differences, 19 differences. The 20th term was the first term plus 19 differences. So we have the 20th term was 3819. We don't know the first term, but we do know that the difference was 200. Was the first term just 19, guys? All right, so then finally we can find the formula they wanted, which would be A sub n equals 19 plus 200 n minus 1 times. Can we just not simplify that one? I think we did enough work on that problem. Is this the last one? Oh, good. All right. So can anybody see how I wrote down here just so that it made sense to us? Can anybody think about how many differences they added? The 16th term plus 24 differences would get us to the 40th term. I'm just trying to keep so that your notes make sense to you. That's how we logicked that through. Okay, we subtracted the term numbers. And got how many differences in here. Okay, then we're going to put in those values. We had negative 73 plus 24 differences gave us negative 217. Ugh. Plus 73. Is that a nice number? Isn't it negative 44? Or did I subtract? 144. Oh, that looks so much better. So then when we divide, it's what? Negative 6. Ooh, I was like, it's not coming out nice. It's because I can't subtract. All right, what do we still not know though? The first term. So I'm going to write down that the first term plus, how many differences do we get to the 16th term? 15 differences got us to term 16, which we knew was, I don't know the first term, but I do know the difference was negative 6, and the 16th term was negative 73. Whew. Okay. Is it 17? Huh. Okay, so final answer. A sub n equals 17 minus 6 times n minus 1, or plus negative 6 times n minus 1. And I'm not simplifying that. That's bad enough. Whew. Yes. There is no delta math for a couple days, and I didn't assign very many of any one kind. So the homework, guys, is to do worksheet 2B. Now, this is my suggestion. If you're going to be here on Friday, we're just having a work day, okay? So go through tonight and do on worksheet 2 either the evens or the odds so that you remember what we just did. But then on Friday, you can go back and do the rest. Does that make sense? Because then tomorrow we're going to talk about geometric sequences, which are similar formulas but different. So I don't want you to not do any practice tonight because I think you'll get really confused when you've learned 2 more formulas tomorrow.